Hello, everyone. Welcome to the Qualcomm Institute. We'll go ahead and get started. My name is Dominique Rossolo. I'm a research scientist here at the Qualcomm Institute. I work with Professor Falco Kuster on the Cultural Heritage Engineering Initiative, and I'm going to bring Falco up here to make a few words about who we are and what we do, and then Dean Della Coletta as well will introduce our guests. So thank you so much for joining us.
Thank you so much, Dominique. Welcome, everyone. It's always a pleasure seeing the friends of cultural heritage engineering at large. I'm Falco Kuster. I'm a professor of engineering. I'm a computer scientist. I'm a mechanical engineer. I'm a structural engineer. But I'm very much engineering. And so as engineers, we have learned how to live within the confines of mathematics and physics. We're really good living inside that box, right? That's very well defined. And a long time ago, we said, well, maybe there's some more, right, to life and innovation, looking at, well, how do we do things right and correct and provably, right, going down the right path. But how do we combine the inside the box with the outside the box thinking, which our friends from the arts, the humanities are so really good at, right? And in particular on the artistic side, many of our colleagues, right, they're really living way out there, and they're really hard to get back into the box. And as engineers, we're really hard to get out of the box that we have so well defined for ourselves. But combining these two, once that happens, we like to call that hitting the exponential. It's truly amazing things start happening. So over a decade ago, we created the foundation for what's now known as the Cultural Heritage Engineering Initiative, where we really looked at how do we take student-driven innovation and really put world cultural heritage preservation, stewardship, the overall understanding and communication to the new level. And our students have truly done a remarkable job. Some of them are here today. Some of them have turned into staff members and colleagues in general. Well, they're all colleagues, truly. Every single one is really an amazing innovator. But before the term STEAM, science, technology, engineering, arts, and mathematics, was really defined, it was already happening here. The amazing thing is that the M also, rather than just representing mathematics, also has now come to stand for music, looking at different ways of connecting with an audience, right, through sights and sounds, through smells, ultimately looking at how do we create empathy towards creating a future for the past. As engineers, we sometimes bias it and say, well, we're really looking at how do we engineer a future for the past. But in our collaborative landscape, right, we really want to take that a step further. So UNESCO defines world cultural heritage as our legacy from the past, what we live with today and what we pass on to future generations. And this is getting harder and harder, right? So the perils of time, aging, the extreme events from hurricanes to flooding to high winds in general, earthquakes and fires, all the way to the human disaster that we sadly have heard quite a bit about as of late. Right? And sometimes even there are the unintended consequences of well-intended actions. And ultimately, you can only drive this forward if we understand our patience, our world heritage at large, and really help move this forward in a consistent yet inspirational way, creating empathy towards what we have out there. Now, when we started this in San Diego, somebody looked at us, cocked their head and said, hold on a second, you're doing cultural heritage in San Diego? UC San Diego is not even 50 years old at that time. I said, how can you do anything, right, with heritage or history? And I said, wow, hold on a second, right? Yes, UC San Diego at that time didn't have much history, but we said, well, there's a lot of history to be made. And so now we're looking forward with our collaborators in Turin and beyond to really shape the digital landscape of world heritage here in San Diego and beyond. So with that, I'd like to hand over to Dean Della Coletta. Thank you so much.
So good afternoon. My name is Cristina Della Coletta. I'm not an engineer. But I'm very happy today because I get to wear another hat. I am very comfortable in my dean's hat. I love my job, but I am even happier when I get to focus on stuff like that, on my research. And I want to tell you a little bit about it because I think that you'll see how being a researcher and a dean come together at the end. And so I've been at UC San Diego 5 years, and this project started at another institution, another premier peer institution in the United States, and this was, let's say, about a decade ago. And the project was going to be divided in two parts. The first part was the archival part, the one I'm good at. I am a literary scholar, a cultural historian. I am interested in the rise of the moment when nations and empires were created. I had an interest in the World's Fair. World's Fairs are ephemeral. They are built and then dismantled. All the materials are not typically gathered in archives. They tend to be dispersed across and among the various countries that participated, or maybe in the town that held the exposition, and they are often lost. So this was a labor, really an archival labor of love, an effort to reorganize in a very structured digital project, and with a pretty powerful database, the enormous amount of materials devoted to the 1911 exposition. And that institution was great to do that. Incredible library, incredible collaborators. But when I started to move into phase 2 of the project, which to me is the most exciting and the most interesting one, which is bringing together engineers and architects to actually recreate the World's Fair, have a 3D reconstruction of the Parco de Valentino, how it was in 1911. I realized that that was not going to happen there. Very strong departments, a real school of architecture, but people spoke different languages and we couldn't communicate. And so I put it aside, moved to UC San Diego, started an administrative career, thought I had kind of put that in the back burner until I met Falco, Dominic, and their team, and it was great having someone who was really interested in collaborating and bringing different expertise together to create something absolutely new and unique. This has been a phenomenal adventure, because then thanks to this collaborator we made friends with our colleagues at one of the premier istituti politecnici in Europe, the Politecnico di Torino, and we have been working together all along. Lei Liang was giving a talk the other day about another collaboration with Falco and Dominic. Lei Liang is a composer in our music department, has been nominated for a Pulitzer Prize, and he said that the thing he loved the most about UC San Diego is that faculty get to become students again by expanding their knowledge into areas that wouldn't be that familiar. I cannot imagine, that's where my dean hat is coming on again, I cannot imagine a better institution than UC San Diego for this kind of interdisciplinary collaboration. There is a spirit of innovation, there is a curiosity, there is an energy, but there is also enormous humility that really allows us to cross those boundaries. I can tell you that when I talk to my friends in engineering and architecture, I probably understand 30 to 40% of what they're saying. If they were to give me a grade at the end of the quarter, I think I would, get between C- and D+. But I'm persistent, and I think there are great things coming out of this type of partnerships. And again, I don't think there is any other institution in the United States that can do it with the extent that we can can at UC San Diego, combining partners in such different fields and disciplines. So I am absolutely thrilled to have my collaborators here today. I am going to introduce them now so that then you can enjoy all they have to say without interruptions from me, and I'm sure they will be able and happy to entertain questions at the end. So we are going to start with Professor Nannina Spanò, who is Associate Professor in Civil Engineering and Architecture and Geomatics in the Department of Environment, Land and Infrastructure Engineering at the Politecnico di Torino. She co-coordinates the PhD program in Architectural and Landscape Heritage and works with the Future Urban Legacy Lab, an interdisciplinary laboratory in which geomatics experts interact with multiple scholars, from designers to economic and societal specialists, in addressing the problems of urban space and bringing knowledge, like Falco said, of the past with visions for the future. She has a number of publications in national and international venues on the 3D documentation of cultural heritage sites and the design of digital applications for landscape and cultural heritage with assessment of quality and use of spatial data standards. The second speaker, Professor Andrea Maria Lingua, he is a professor of geomatics in the Department of Environment, Land and Infrastructure Engineering at the Politecnico. In 2017, he helped found the Politecnico Interdepartmental Center of Service Robotics, and he's the author of more than 200 papers in national and international journals, books, and conference proceedings. And his research are related to research and innovation in photogrammetry, computer vision, unmanned systems, laser scannings, outdoor and indoor positioning, data fusion, and many other things that you can read in the brochure for the sake of time. Finally, last but not least, Professor Filiberto Chiabrando, who is Associate Professor in Geomatics in the Department of Environmental, Land and Infrastructure Engineering at the Politecnico. And he also holds an adjunct position in the School of Technology at Michigan Technology University. His main research interests are also related to photogrammetry, unmanned aerial system, laser and sensor integration that is often integrated with cultural heritage documentation in architectural and archaeological context. He has authored more than 150 papers in national and international journals, books, and conference proceedings. And it is my pleasure now to welcome Nannina to the podium. Thank you.
Thank you so much, Cristina. We are very proud to be here, and we are very happy. I apologize for my English, but I will do my best. So I can start the presentation. I'm going to tell you about geomatics for cultural heritage at Politecnico di Torino. Since I'm the first of us to speak, I will introduce you our labs, our department at Politecnico, and some synthetic information about our university and our city. After explaining some issue about of geomatics application in the domain of built heritage, my colleague Andrea Lingua will enhance with some more details and strategies about emerging technologies of geomatic involving other fields of study and applications. And at the end, Filiberto Chiabrando will explain in details the 1911 project that we share with the group of Cristina Della Coletta. Is it okay? Okay, so here a brief outline. Our lab is titled the Geomatic Lab for Cultural Heritage, pertaining the Architecture and Design Department, which is the closest to the Division of Art and Humanities of UC San Diego. and which represent a part of architectural area of Politecnico. Oops, sorry. In the second part of my speech, I will try to introduce you the main purposes we adopt in the cultural heritage documentation and surveying, and into the issue related to the representation of architectural heritage in the mapping domain. The last part, which focuses on the interdisciplinary cooperation with other specialists dealing with conservation of built heritage. And at the real end, I will introduce you briefly our student team. Recently, Humanities has undergone a huge innovation in the framework of 3D surveying, positioning, navigation. In fact, spatial data management system and survey instrumentation is undertaking a rapid evolution toward precise, efficient, and many times low-cost development. Many geomatics innovations improve the use of spatial and geographical data by numerous fields of investigation that benefit from the possibility of managing location-based data and information. Such innovation enhanced our daily life and influenced the way we imagine the future. But let's start with our group. Here you can see the members that are a few full professors, many associate professors, researchers, PhD students, research fellows. Within the richness of our group arises from the youngness and the passion for our work. We are divided and adhere to two different laboratories, each of which is involved respectively in the area of architecture and engineering of the Polytechnics. The School of Architecture and the School of Engineering are the two main souls of Politecnico. We can say a few words about our university. It is an expanded campus, mainly towards east. Even though there are many links and research relations with United States University, our rector and our entire community esteem a lot research activities and relationship with you beyond the ocean. We have many different bachelor and master courses, adding to several specializing master courses and PhD programs. The courses taught in English language are increasing, so as the PhD programs, since many foreign students of different learning level candidate themselves and succeed to study in Turin. In this slide, we show you the pilasters of a European Community Research Program titled Horizon 2020 that our departments follow and are connected to. In fact, the Department of Architecture and Design, briefly DAD, is the leading branch of learning of the Turin Polytechnic, focusing on the art and science of design, architectural and urban buildings, and product and cultural heritage design. The DID promotes, coordinates, and manages basic and applied research, teaching and training, technology transfer, territorial services related to architectural and urban design, including sustainability, economics, and financial aspects, as well as restoration, enhancement, and management architectural, urban, and landscape heritage, and industrial, graphic, and virtual design. Here we can see the two PhD programs available at the DAD. Our Gematic group adhere to architecture and landscape heritage. This is the second, and we have cooperation with the one titled Architecture, History and Project. Now, a short video presenting our city, which is Turin. It is located in the northwest of Italy, near the Alpine area. We start with an aerial point of view of our city.
Torino, a city where everything's possible, with a story to find out, and where the beauty of the past coexists with the present of innovation. A city where culture is the driver of projects, events, and spaces. Where you can move and live in many different ways. A city that is a surprise from all points of view. And good to taste at all times. Where it's easy to get lost staring up at the urban architecture. And where you can enjoy traditional and unexpected flavors. A city where having fun sounds natural. This is Torino, a city with endless possibilities.
Okay, this is as being realized from by our colleagues from Politecnico, and maybe Torino is a good place where to connect legacy of the past and future development. So we can go on. And coming back to our lab activities, we basically deal with the optimization of 3D models generated from reality-based methods. That means using photogrammetry, terrestrial laser scanning method, and recent development of such techniques. The generated models are also named as built models. Different representation and format models, such as digital surface models and their derived products, such as orthophotos, are dedicated to specialized analysis. We can refer in a very schematic way that the models we aim to build are characterized by some common parameters and generated with great attention to the intrinsic requirements that the final product have to guarantee. Most of time added to morphological and geometric features, constructive system, architectural evidences, materials and materials decay have to be represented in detail. In addition to the scale of survey, the metric accuracy and the richness in detail have to be validated, and generally we obtain multi-scale, multi-source and multi-temporal models, in which the effectiveness of 3D cloud or mesh models are highly recommended as high resolution and metrically constrained textures. Also, the landscape dimension is held in high regard in many projects. So, most of the time, the context in which an architectural asset is located is important as the asset itself. This is a video about Novalesa Abbey, which is a very old abbey in Piedmont, one of the oldest, and it is on the direction between Italy and France. Now, about the user-oriented issue, the 3D models, the digital about the user-oriented issue of 3D models, the digital environment where we can manage models is crucial. As known, the BIM platforms are able to satisfy the need to archive and share different kinds of information connected to the model. Historical BIM, also said HBIM, is a domain that attracts a lot of attention. since the generation of the models starts from an as-built point model, and it offers the chance to manage the semantic dimension of real object using a parametric model. Currently, BIM environments enable to provide features recognition and architectural segmentation of points model, with many criticalities indeed, but almost and hopefully in an automatic way. So, level of details, grade of generation, and grade of accuracy are schematically proposed and are becoming a standard. A final context that I would like to mention is the critical issue related to the representation of architectural heritage in the domain of high-scale cartography. This is a huge field of study since the integration issue of BIM and GIS are involved. So interoperability is a paramount issue. We started to analyze and extend existing standards of geometry information data. This integration and extension have been proposed on the basis of other standards available for the architectural scale knowledge representation. So we reached to represent a segmented model providing information also involving a seismic directive available for Italian territory using spatial data standard in a GIS environment. Now, a quick overview for presenting our interdisciplinary cooperation. One of the main fields of study we cooperate with is archaeology. Here an example of rapid mapping documentation derived from the drone photogrammetry in the theater of Hierapolis, which is a Roman city in Turkey. And here the corresponding amazing colored point clouds. Archaeologists esteem very much the aerial point of view. Maybe we have to start this. No? They have to change? I will. No?
Looks like
we didn't test this one. We should have seen different orthophoto about different here changing. It is to explain that archaeologists esteem very much the aerial point of view with the multitemporal and connected with multitemporal data and orthoprojected data. These orthophotos are obtained from a co-registration strategy. That means that we are able to measure control points only first time, with the aim to reduce the time spending. Another interesting point of view of geometric method we are presenting is that outcomes are referred surely to the documentation phase, then even to the multidisciplinary investigations, and lastly to communication and dissemination strategies. We can see in this video a connection between points and mesh model with the reconstruction hypothesis. Okay. A second main field of study with strong cooperation in the structural evaluation of architectural structures, pertaining both ancient and historical eras. There is a need to schematize models in order to optimize simple models from the geometric point of view, but very adherent to reality. Strategies and algorithms to realize automatic digitalization are very interesting and studied. There would still a number of other fields of study with which we collaborate. Historical studies and restoration are the more frequent, but we still want to point out the discipline of geophysics. Here we are in the Valley of Kings in Luxor, Egypt. The first objective was topographic measurement and 3D mapping in support of geophysics survey. that was applied with the aim to search anomalies in the underground that may support the hypothesis of buried structures. Very many, in this video you can start the video. In this video you can see an animation of ground penetrating radar application in the entrance area of Novalesa Abbey. Our colleagues with us discovered that surely some buried structures were present at the depth of about 90 centimeters. Okay, thanks. Very many results that you saw in this presentation have been realized with the cooperation of many people involved in our direct team, which is a student and tutor team formed some years ago, whose activities in the recent years has increasingly linked to geomatics emerging technology. The acronym explains the goals of the team. In an era in which the topic of risk prevention and risk management and post-disaster response are unfortunately very current, we decided to establish a permanent training activities for students of many degree courses in architecture and engineering. In this slide, you can see 2 examples of stage purposes to face in the past, and with the next video I show you a more recent extended experience applied in the area of Central Italy earthquake of 2016 and 2017. This is the Marche region and Tolentino city. We focus at our Eastern survey in the sanctuary of San Nicola, which is a very popular. This is the magnitude of the earthquake in this area, and then this is the starting of the exercise that we make with students. The sparse and dense cloud that we carried with different drones. You can see that the complex is basically huge, the church, the cloister and other buildings. We acquired data in indoor and outdoor. So now here is the in this video only the inside of the church is focused. So you can see that we split from the video to the clouds. All the experience and the video has been realized by students, and so you can see the section profile to explore the complex. Now the analysis. You can see the colored map that show the level of the structure, and here the mesh models, the editing, and some analysis comparing the geometry with some poor geometries like a sphere, in order to compare if the structure has been damaged. Then, this is about the hand. So I can give the floor to my colleagues Andrea Lingua. Okay. Thank you so much.
Thank you Thank you, Nanina. I would like to thank you, Cristina, and your collaborators for organizing these experiences that blends architecture, engineering, and humanities. Excuse me. I apologize also for my English not so good, but also I try to give my my most impressive performances. Then we start my presentation with a brief introduction on the vision at the Politecnico di Torino devoted to innovation and emerging technologies, describing some examples of three different approaches: the vertical research project, the thematic projects, and the inter-multidisciplinary projects. I will finish with some experience of innovation in the didactic field. Recently, the Politecnico di Torino developed the strategic plan defining that the Politecnico's researches have to be devoted to the definition of whole pipelines from problems to solution, using three particular approaches. The first, there is a laser, I think, about, no. It doesn't work. It doesn't work, but okay, it doesn't work. The first, first contains the vertical researches that comes from problem to solution using a unique specific approaches with unique specific discipline. Sorry. The second is the thematic project that including a small set of disciplines, often close to thematic terms. Then the third is the development of inter and multidisciplinary study, then involve many disciplines, even far apart, to solve complex problems. I selected two examples of vertical projects. The first is the seamless positioning. The problem of seamless positioning comes to answer the question, where am I? An information more and more necessary in this age, I think increasingly requested in the future. In outdoor environment, the solution can be obtained from a common smartphone with a GNSS receiver. But there are many other zones in complex urban area, as indoor areas, as urban canyon, and so on, where this solution is not available. We need a new technology to solve this problem. The image recognition-based location is a possible solution to this problem. First, on right, first of all, it's necessary to produce a database of images, of solid images, RGBD images, georeferenced, using the 3D model described by Nanina Spano. Then the user take an image with his smartphone, and the ERBL algorithm compare this image with the whole database, extracting the most similar one. At the end, these images are used to localize the user in a more accurate way by means of a photogrammetric approach. This solution can be mixed with other positioning techniques like GNSS or ultra-wideband if are available. The second example of vertical project developed by our group is the autonomous car navigation for parking, founded by an industrial company, the Magneti Marelli, that I think you know. We proposed a solution based on a structured environment with ground control point, with coded ground control point. The algorithm automatically extracted the GCPs from images and compares some images along the sequence, calculating the car trajectory in real time for a maximum speed, in this case of 40 kilometers per hour. As you can see on the left, in this figure, the final accuracy is of about 20 centimeters. Okay, a good result for car parking. An example of thematic projects is the climate change at Polito, a national project for excellent department won by DIAT, my department, in 2018. In this case, some disciplines on geoscience are involved for monitoring the environment in different scenarios: glaciers, caves, urban areas, rivers, and this is the case, and so on. Proposing solution to mitigate the climate change and defined action for adaptation. The study are realized using a new integrated laboratory that include 5 multi-site units: the Glacier Lab and the Paleo Lab and the Moving Lab, that are able to acquire data on the land, the Green Roof Lab to experiment some solution for sustainability of roof and for the energy part, and the Core Lab that collect data and analyze this data. In 2017, the Politecnico di Torino founded 13 new interdisciplinary centers for a correct approach to inter and multidisciplinary problems. Nannina and Filiberto was involved in full. I and Filiberto also in PIC for SER, that is the Polito Interdepartmental Center for Service of Robotics, that I try to describe in next video. Service robots assist human beings, typically by performing jobs that are dirty, dull, distant, dangerous, and repetitive. They are typically autonomous and also operated by an embedded control system with manual override options. This is a video, please excuse me. Pick4Sale contains many people with different competencies in electronics, in mechatronics, in mechanics, in informatics, in design, and in geomatics for a multidisciplinary approach to the problem. This is a modular schema of a service robot. I think is not so boring. Some sensors allow the perception of a physical real world, can be processed using inferences algorithm, producing experience by means of classification and deep learning techniques. The seamless position allows the robot to know its location and the location of close real objects for activated movement and actions. The geomatics can be interact with this component in green, the green area. In this slide, I summarize all of possible sensors that can be mounted on different vehicles to solve the perception step. Imaging as RGB cameras, multispectral cameras, thermal, hyperspectral camera with 100, 200, 300 different bands acquired to the object, LiDAR, and some possible vehicles, unmanned, aerial, and ground vehicles. The acquired data can be processed using quasi-real-time photogrammetry to produce 3D point clouds, as Nannina described a few minutes ago. This is a 3D model of an industrial site acquired using unmanned aerial vehicle, RGB imaging, and the student team direct. Using deep learning techniques, it's also possible to analyze the image sequences acquired, for example, by UGV for classifying and extracting data, in this case, fluids and trunks, in automatic way. These summarized enabling technologies can be applied to solve more complex problems, for example, in the precision agriculture field. In this case, UAVs automatically acquire images for 3D mapping and plant health monitoring. UAVs can collaborate with UGV that can automatically realize irrigation, fertilization, weeding, and other agricultural works. The farmer only supervises the activities. This is a simple example of the collaboration between UAV and UGV. This video shows the 3D point cloud of a vineyard obtained by UAV images that permits the classification of vineyard rows used by the UGV for correctly navigate in the vineyard area. These enabling technologies, the enabling technology of Pick4Sale can be applied to improve utilities for smart city. In this case, we implemented many different sensors to locate a bicycle equipped for monitoring pollution parameters a long time. In this case, the sensors are able to acquire data on PM10, on methane, on ozono, and so on. And this is an example of the result. In this case, in this slide is shown the concentration of PM10 to explain the quality of the air. The red area have a poor air quality and the green area have a good air quality in the time. But all of this system, we can also apply these technologies in complex environment, also as your laboratory. We have also the Blue Rove. In this case, we apply these vehicles to make a survey of an underwater structure for the production of energy. Is a submerged part of a dams. In this case, this is the dense cloud, and the images used to produce this. The innovation in geomatics at the Politecnico di Torino is also connected with innovative didactic approaches to course and lectures. In this case, the video explains a new course for architects and engineering on UAV for surveys of land and architecture that apply learning by doing approach. It's an Italian, but with the subtitle in English. Excuse me.
Da lì ho deciso di iscrivermi per provare cosa volesse dire usare i droni.
Le attività del Politecnico di Torino nell'ambito dei droni iniziano nel 2006 per il rilievo di ampie porzioni di territorio in casi di emergenza. Dal 2009 sostanzialmente abbiamo cominciato anche delle attività con droni multirotore.
Abbiamo studenti con differenti background, futuri architetti, studenti che hanno studiato pianificazione territoriale, che stanno studiando ingegneria civile, ingegneria aerospaziale. Le attività sono sostanzialmente divise in due fasi, una prima fase che riguarda lezioni teoriche su fotogrammetria digitale e computer vision, dall'elaborazione dei dati e la realizzazione di modelli tridimensionali. Una seconda parte, una parte invece un pochettino più pratica, riguarda sia la sperimentazione e la prova dell'utilizzo di questi sistemi in appositi spazi dedicati al volo dei droni, ed infine la parte di laboratorio sull'elaborazione di dati. La speranza che al termine del corso sui droni i futuri architetti e ingegneri siano in grado di utilizzare queste piattaforme per la loro carriera professionale.
Nelle operazioni che abbiamo svolto a seguito del terremoto del 2016 in centro Italia abbiamo visto negli studenti quell'entusiasmo, percepito la potenzialità di un corso che fosse effettivamente trasversale. È molto importante che queste tecnologie possano essere trasferite ai nostri studenti.
Credo di aver cambiato un po' l'idea e la visione del mio futuro. Mi vedo più fuori col drone, misurare, che in ufficio a battere col computer. Non vedo l'ora di finire l'università per poter scoprire cosa mi aspetterà.
Non si legge. Thank you very much. At the end, the student team, our student team is direct that permit to mix. Excuse me, only a moment. Excuse me. That permit to mix the learning by doing approach with public engagement and social purposes. In this case, the final video described the activity of Team Direct to aid the civil protection and firefighters during the earthquake in central Italy in 2017. Thank you very much.
Okay. Good evening to everybody. First of all, I would like to thank you, Professor Cristina Della Coletta, for inviting us here in UC San Diego, and as well Dominic Risolo for giving us the opportunity to present our works in this beautiful room. So I will start the presentation on the project with a first overview of the Torino 1911 project, and then I will move to the ongoing activity. So the aim of the project is related to rebuild the 1911 atmosphere using multi-source and multi-temporal data in order to follow an interdisciplinary approach where ICT meet the humanities. We use different methodology, mainly connected to geomatics techniques for testing different visualization tools. So the perspective are to improve the knowledge of the Torino 1911 exposition, and probably in the next future to evaluate possible virtual reality, augmented reality tools for education. From our side, the main research topics are related to geospatial data acquisition and processing, and to 3D modeling and visualization tool. And we have the aim to develop some new research connected to new tools for 3D data acquisition and processing, and finally to development of geospatial database for data dissemination. So I will start with an overview of the two main case studies. This is the video that will start in a bit. You know that we are inside the Parco of the Valentino, and especially we have worked very hard in the Valentino Castle. This is the Valentino Castle that actually is the headquarters of our department, the Department of Architecture and Design. And here we have the Borgo Medievale. So the Valentino Castle was built in 1630 and was originally a residence for the royal family. And actually we have offices from the staff of the Politecnico, and we have as well some classes. Here is some drone views of the Valentino Castle. And very close to the Valentino Castle we have another interesting city that was built in 1884 and is the Borgo, the medieval Borgo, or Borgo Medievale is in Italian. This complex was built by Francesco d'Andrade in 1884 for another exposition inside. This is an overview of the Borgo for another international exposition in the Parco del Valentino, and it still exists. Naturally, it's not original because it's a copy of several medieval building that we have in the Piedmont area, and this is the castle that we call as well Rocca. So we can move now to the ongoing activity of the second year, because we have a lot to see. First of all, according to the aim of Cristina, we improved the historical research. We moved to several archives in order to improve the documentation. Then we finalized the LiDAR survey, and we carried out as well some UAV survey, and we processed some aerial data. Then we try to make some 3D modeling of the old pavilion that actually doesn't exist, and finally we are working on the 3D GIS and database. Actually, the historical research are focused on the Fondazione Marazza, where we found the Archivio Molli. Stefano Molli was a designer of the Torino 1911 exhibition, and we were very lucky. We found more than 500 original drawings totally unpublished, and actually we are cataloging it in order to improve the historical documentation. This is a very, very rich archive, and at the same time we found in papers and other sources another interesting pavilion, that is the Hungarian one, and we will see in the next slide the 3D modeling of this part. Moreover, we finalized the 3D modeling using LiDAR data of the main floor of the Valentino Castle, and in this case we found we need to share the information connected to this floor, and we found an open source 3D viewer. This 3D viewer was developed by the National Research Council, and it is possible to make some query. We can cut the model in order to see the real shape, and in this visualization here we are able to measure the shape of the object as well, and we create a kind of web tools where it's possible to go inside of the different rooms, and as well it is a more detailed room where we are able to visualize the LiDAR point cloud, the photogrammetric point cloud, the SLAM point cloud, or a LiDAR mesh. This is a mesh of the floor room. After that, we carried out and we finished as well the external LiDAR survey. These are some views of the LiDAR survey, and finally, after 1 year, we obtained the authorization for flying over the Valentino Castle and the Borgo Medievale, and we performed the flight with the UAV following a traditional photogrammetric approach. So first of all, we measure some ground control point, and then we perform the flight. In this case, we perform a traditional double grid flight with nadir images and oblique images as well, in order to obtain accurate 3D models. This is a visualization of the dense point cloud, and this is the final textured model. And an orthophoto for documenting from a good point of view the area. At the same time, so this is the resolution, it's not very good. At the same time, we carried out the complete point cloud of the Borgo Medievale in order to make some visualization of this tool, and the UAV flight as well, following the same approach that we follow for the Valentino Castle. And here we can see the flight path. We made a double grid, but here in this case we carried out as well a circular flight according to the particular shape of the Borgo Medievale. Here we can see some 3D view of the object. This is the 3D point clouds carried out by the photogrammetric process and some 3D textured view. And here in this video we have tried to we have tried to summarize all the processing step and all the surveyed data that we obtain from of the area of the Borgo Medievale. It is a traditional flight, and then after that we will move to the UAV point cloud, again from an aerial point of view. Then this is a point cloud carried out by a mobile mapping system, a SLAM system, and here is it possible to make a tour from the terrain. Unfortunately, actually, this system doesn't allow to color the point cloud, so this point cloud is only in black and white, but we are working to improve the system as well. And we performed the survey in the external part and with Cristina and Eric and Dominique as well in the internal part of the Rocca. This is the internal part of the Rocca. That is the castle that we have seen in the Borgo Medievale. So actually this part is a museum open only during the summertime because in winter it's very cold, and Cristina and Dominic probably remember the temperatures during our surveys. Okay, and so this is a little part in the outdoor. It is a LiDAR point cloud. Okay, so this is the main entrance, so we can move to the next one. And starting from the traditional products, we have tried to make something new, and in this case we have tried to realize a UAV with a multi-sensor data integration. So we use a traditional Phantom from DJI plus a 360 camera, and in this case we use the Fusion GoPro. And we carry on the Fusion GoPro directly on the Phantom in order to make some tests. Here an overview of the 360 images, and we found very interesting results from our geomatics point of view, because if we combine the traditional frame images with the 360 images, we are able to improve our accuracy in the final product. Here in those two tables we can see that we have an improvement in the accuracy, and it is a good result for our measurement point of view, but as well we are able to extract non-conventional view. It is a 360 image of the Valentino Castle from a low elevation point of view. It is an highest elevation point of view, and we realize here what happened? Okay, here we have as well another 360 image of the Borgo Medievale, and another very interesting tools is to realize a 360 video from a non-conventional point of view. And here you can see a short video where it's possible to see the flight, and we can navigate in the 360 environment, and this is very useful because we are able to see all the environment, and we can interact with the video, and we can move everything around. And so this is a very new product, because I think that I never seen before. So with this system, it's possible to combine the video acquisition with the traditional frame acquisition, and so to have in a single flight a lot of data, a lot of information, and this is not usual. Okay, maybe we can stop and move to the next slide. Okay, more than singular surveys, we found, fortunately, an aerial survey carried out by the municipality of Torino, and we use the images related to the Parco del Valentino in order to realize a 3D model of the environment. And this is very important, since another objective of the project is to rebuild more or less the 3D models of the pavilion, and to insert the pavilion on the environment. And so this is a result, and this is the orthophoto that is the same area of the old maps of Torino 1911 project. So for the 3D modeling we started actually, and I will show you the Hungarian pavilion. This is a 3D view of the Hungarian pavilion. We follow a strategy. Naturally, we collect some data, then we make some geometrical analysis. We started from the 2D drawings according to our architectural Humanities, then we moved to the 3D building modeling, and then we insert the 3D models in the context. It's not very clear, this slide, anyway. So first of all, we are looking for the position of the Hungarian pavilion. The Hungarian pavilion is on your left. Was very close to the Valentino Castle during the international exposition, and we look for the archive material. We found some postcards, and as well we found some historical images, historical videos. We found some drawing in different papers, and naturally we use as well the general plan of the 1911 exposition. So we started from this plan, and this is a video again, and this is the first result of the facade. So this is our first drawing using AutoCAD, and starting from those information, this is the plans, we move to the 3D modeling phase. Actually, these are some 3D view of the Hungarian pavilion. Probably the shape was more or less the same. And in order to better understand, this is a video again, in order to better understand the real shape of the object, we perform a architectural composition in order to understand the connection between the windows, the roofs, and so on. And here other results. Unfortunately, actually, we don't have a
photorealistic texture because we really don't know the material and the real color of the pavilion. These are some hypotheses. Maybe we will work on it with Cristina and the group of Cristina, but these are some 3D interesting views. This is another view, the main facade, and this is another view. Naturally, we want to position the 3D models on the old site, probably. And so we use the 3D model, the historic and exhibition plan, and the photogrammetric mesh carried out from the aerial flight. And actually, this is more or less the 3D view. In the left side, we have the Valentino Castle, and here, there is not the point, I'm sorry. Here we found a kind of terrace that actually is a boating club, and here you can see that there is a connection between the old pavilion of Hungarian and the actual boat club. Probably this is a remaining of the Hungarian pavilion, but we need to go in deeper in this research. So the last step, and I'm going to close my presentation, is the realization of a 3D GIS and a connected database. So for this aim, we started from the conceptual model of the website of the Torino 1911. This is the conceptual model that is not actually related to the spatial components. So we make a lot of tests, but we were not able to connect in a good way this database with our geospatial information, and for this reason we try to realize a new conceptual model that allow us to connect features, media object, and GIS content. And this is more or less the video of what we did. We start with the implementation of a Postgres database. So we insert all the data related to the pavilions, the images, and so on. And then we connect all those information to the geospatial data of the municipality of Torino. So this is the map of Torino, and in light red you can see the drawing. We redrawn the old pavilion, the pavilions that are present during the 1911 exposition, and the Castello del Valentino and the other things as well. And we use historical map, so it is the map that we are able to see, and we found as well a 3D map and 3D old map and representation. And then we connect the spatial information with the database. This is an example on the Hungarian pavilion. So we have all the information. We have as well a connection with the images, so the archive images. Here we can see we have a media link. This is an archive image that is connected, and as well we have tried to connect the 3D models. So we made an external link to connect the 3D model in order to explore not only into the old documentation but in 3D as well. And this is an example for the Valentino Castle as well. In this case, we connect the Valentino Castle with the 3D model that you saw before. And here is possible with this link to measure, to make some query, to visualize all the part of the main floor of the Valentino, and we can go in deeper in the single room, and naturally we are able to make some 3D GIS visualization. So some conclusion, or better, the further works that we need to deal with First of all, we need to improve the historical research. We are still in progress. We need to find other material in other archives. Then I think that we need to connect with large-scale data acquisition the two main surveyor sites, the Castello and the Borgo Medievale, maybe using mobile mapping system, the ZEB, Rivo could be an instrument, because actually we are working to insert the color in the SLAM system, and this could be a good way for have a good connection. Then for sure we need to improve the visualization tool, and we are here for this topic, because we want to use VScore that is developed by the group of Falco, and after that we need to carry out the other 3D models of all pavilion. The monumental bridge and the city of Turin pavilion are our final objective, and we need to solve the problem with the database connection between the website and our approach, and probably at the end of the project move the system to web GIS. Naturally, the work was carried out in a large group. These are the people of that work with me and Nina and Andrea and other colleagues in the laboratory of Geomatic for Cultural Heritage, and so I appreciate a lot their work and that I presented here. So thank you very much.
I think we have time for a few questions for all three of our colleagues.
I didn't see any photos where you use like VR glasses to examine the data that you have. Is that a technology that you utilize, like the Oculus Rift?
Yes, the 360 video could be visualizing using the glasses, but actually we don't have this device. But is it possible to use this system with the VR system and to see in 3D all the video as well?
I'm curious about the archival data that you're using. Obviously, you're using historical maps.
Yeah.
Is there any place for using text as well? What are I mean, how do you, if you can go into the archives and find anything about this space?
Yeah.
How do you put that into practice?
Actually, we focus our research on the drawing and on the maps, because maybe we will work with Cristina on the other documentation, because actually we are looking for the maps and for the drawings, because we need to realize the 3D modeling of the pavilion that disappear in this year. So for this reason we are looking a lot on that, but naturally we found a lot of not drawing documentation, and we need to insert it in the final database in order to have both traditional information with drawing, 3D models, and so on.
So there was a magazine or a number of magazines that came out throughout the exhibition preparation, during the exhibition and after, and we were actually able to purchase them, except that they're now at the special collection of my previous institution.
Yeah.
But we digitized them all, and they are on the website. So they are digitized and available on the current website.
Another challenge is that from the Cristina studies, maybe raise some intangible asset resources, and maybe our focus is to put inside the database intangible resources.
Yes?
Well, you three professors have got my cerebral molecules going. But my problem is that I'm looking at the sun, the moon, and the stars.
Yeah.
So I'm looking for a common denominator. Really. Yeah. If I were a student today, I would be looking for how do I pick one of these wonderful areas to specialize in. And as a professor or as professors, that would be, I have a few questions.
Yeah.
But one would be, is how can you identify a smart student that has a particular proclivity for whether it's architecture or whether it's art or whether it's engineering, and direct them in that particular vein.
Yeah.
Now, if I were a student today, I could pick any number of cities in Italy that I'd rather go to than American cities because of your heritage, cultural heritage with that wonderful architecture. For example, I.M. Pei, great architect, just died. So what did they do? They showed him with this glass tower at the Louvre in Paris.
Yeah.
And unless you get that kind of experience, and you can get it in Italy. In fact, you mentioned everything except medical, but I can help you there. You can go to Padua, they got a great medical school. But Italy is rich, whether you go to Rome or you want to go to Pisa, you want to see engineering, how about the Leaning Tower of Pisa? Not when it was built, but how about now, trying to stabilize it with concrete to make it right. So here's the point. There's all these things to deal with, so as a professor, the word kind of has me stowed, which is geomatic. Is that like a polymath who knows everything? Is this bringing everything together? And I think there's two other words that have to go with it, because you're talking about interdisciplinary.
Yeah.
But I think along with that, you need networking, and along with that, you mentioned connectivity. And if you get all of these together, then maybe you can help a student kind of work together to make some choices.
Yeah, this will be the last stage of the project. Actually, we are collecting data and we are working on the 3D visualization, but naturally after that we need to make some tools, and we need to find a good way in order to make some query on the data where it's possible to understand I don't know, the constructional phases, the history of the object. We need to improve the interaction between the product that you have seen here with more multidisciplinary approach. But this will be probably the next step and the aim of the 3D GIS platform. Because actually we have worked a lot on collect material, but we are not at the end of the project. We are more or less at the beginning of it.
Well, so exposure is very important.
Yeah. There was, maybe she was before.
I was wondering if you could go back to the first conceptual model, which you skipped over pretty quickly. And,
yeah,
and
this one.
Yes. Why was that set aside for the second conceptual model?
Because there was a problem to connect the spatial data with this conceptual model, because there was not a unique number, or I don't remember, Nanina, correct me if I'm wrong, because
all database lose many relations, and so even the many ID codes. So had to be reconstructed.
This was a technical problem, probably, and we need to discuss with the staff of Cristina about this problem. That maybe we move back to this conceptual model if we will be able to connect all of those information with the spatial information, because this is our objective, to connect this information to the spatial one, and sometimes was impossible with this conceptual model.
So part of the problem is historical, because I started the project, as I said, at another institution, and ideally we should have had part 1 and part 2 together, right? The archival part and this part, but we didn't. It came into different, two different groups, and we're trying to re-engineer it again, and that's just bad luck.
Let me start by saying I have a degree in history, so I'm going to throw a bomb like Americans like to do and see what you do with it. But it's a straw man. My 17-year-old has a love for video games and is involved in incredibly rich 3D environments all the time. What's the best case for spending all this time and effort to attach this to reality instead of just letting the game makers create, thought-up worlds?
So, okay, this is. If I understand well, those are not all of the survey are related to the shape of the terrain. Are not are with a correct scale, are in a correct reference system, and so we can measure it, and we can maybe make some query about that. The video games more or less are totally without any connection with the real shape of the world. So
it makes it so much easier that way, though.
Yeah, maybe yeah. Maybe yes.
Yeah, another comment. I think
Yeah.
it was Andrea. He showed a picture of the cell phone up there. The cell phone.
Yes,
Isn't that
Andrea,
right?
cell phone, the smartphone, yeah.
To make a point.
Yeah.
Well, I think that from your standpoint as professors, it could be your worst enemy or your best friend. Because first of all, how do you get your student when they come into the class and you're trying to talk to them, put the damn thing away?
Yeah.
And the second thing is that unfortunately, too many students rely upon it. They don't create interpersonal relationships. In other words, they don't build a personality. And maybe they fail to take advantage of a professor who's trying to turn on their mind to get them to do something productive in life.
Yeah.
It's a problem.
This is a problem as well, but maybe we will be able in the next future to solve this problem. Maybe yes.
Well, thank you. Oh, you have a quick question?
Yeah. So, in case of your the Hungarian Pavilion project,
yeah.
what will be the objective of this specific project? Do you want to build the same database of the 3D point clouds, the same you have as the Politecnico Castle, or is something?
No, the Hungarian Pavilion doesn't exist.
Yeah.
So it's totally a 3D models of the history. We use some old documents in order to rebuild these, and actually we did only a 3D models, but probably in the next future we need to improve the model, maybe in a BAM environment in order to insert more information. But actually is only to understand the shape and to understand maybe we will at the end we will be able to connect the terrain with what happened today.
I can add one thing. The Hungarian pavilion was unique. So in general, the Turin 1911 was created by Italian architects following a style that was called the Turinese Baroque, and there's all kinds of political reasons why that happened. The Hungarian pavilion was created in a completely unique architectural style by Hungarian architects who were very much connected with the movement of Hungarian nationalism. And so they brought in that particular style to make a very specific political statement in the Europe of 1911, and the war is not too far away, so it's very important to understand how these particular these buildings were not only works of architecture, but they were very strong socio-political and cultural statements in a landscape that was not neutral at all.
Thank you. I guess we have one more question. And then
well, it's really just a comment about the video game, so-called question. I mean, this work is so important because for us as historians, we want to understand the experiences that people had in the past. We don't want to just make stuff up. And we all know that when you walk into a certain space, you're interacting with a certain space, it gives you a very a certain feeling. Being in a cathedral is not the same thing as being in a movie theater. And so with this kind of tool, we can begin to put ourselves literally in the places, in the shoes of our historical subjects. And that's very important for us historians, you know. And it's important for our students because if they can learn that kind of empathetic understanding of the people of the past, they can begin to have empathy with their people in foreign countries who have a different experience. And, you know, so this is just really cool stuff, I think. So thank you very much.
That's a great final comment.
Yeah, super great.
Before we break to mingle a bit, I wanted to thank our amazing staff here at Qualcomm Institute, Max and Ruben and Hector here as well. And then also what makes this research possible on the second floor of Atkinson Hall, definitely want to acknowledge Dominique Meyer, Vid Petrovich, and Eric Lowe for really powering a lot of what we do here that's going to make this collaboration sort of continue to grow. And then finally want to acknowledge Farshid back there, Basmandigan. He is responsible for so many wonderful things happening within the Division of Arts and Humanities, a driving force, and thank you, Farshid, also for helping to bring all of this together. So thank you all for joining us, and please stick around.